Students, in our previous video, we were studying the quick review of the electrochemistry. So in this video, we will continue it and we see the another topics. Okay, the next term is efficiency of fuel. A fuel cell. If we want to find out the efficiency of fuel cell, then it is given by the formula del G upon del H. Here del G is the change in the free energy and del H is the change in the enthalpy. We know del G is given by minus NFE, so we can put this value. So minus NFE divided by del H. Here N is the number of electrons involved, F is Faraday and E is the EMF of the cell. By this formula we can calculate the efficiency. Further, another formula is about the free energy of the reaction. In exam, it may be asked to calculate the free energy of the reaction. Okay, this is calculated by del G naught is equal to summation of the free energy of all the products minus the summation of all the free energies of all the reactants. So if we know the free energies of product and reactant, then by this formula we can calculate the free energy of the reaction. Then the another thing is to find out the value of del G or del H or del S. If we have given the EMF of the cell, then how we can calculate? There is a formula for it. Del H is given by NFT del E naught upon del T at constant pressure minus NFE naught. Here this term is what? Del E naught upon del T at constant pressure. This is called the thermal coefficient of the EMF. Okay, by this formula we can calculate the enthalpy change. Then if we want to find out the entropy change, then it is given by NF times del E naught upon del T at constant pressure. If we know the value of del H and del S, then we can calculate the value of del G by the formula del G is equal to del H minus 3 del S. In June 2018, a question was asked based on this formula. So we will solve this problem, and the question was the standard cell potential of a cell, we have given this cell, was measured over a range of temperature and we have given the data. It means we have given the standard EMF's value, that is this. The standard reaction entropy in joules per Kelvin per mole and enthalpy in kilojoule per mole at 298 Kelvin. We have to find out this. Okay, we have given the standard EMF. For this formula, we should know the value of the thermal coefficient of the EMF. It means we should know the value of dou E naught upon dou T at constant pressure. For this, we will differentiate this standard EMF with respect to temperature at constant pressure. Okay, this term will become equal to 0 minus, here we will get 1 into 10 to power minus 4, 1 minus 0, minus 2 into 10 to power minus 6 times 2, 298 minus 298, 1 minus 0. Okay, so here we will get 1 into 10 to power minus 4 and this term will become equal to 0. So the value will be minus 1 into 10 to power minus 4. Now we have to find out the value of del S, that is given by the formula NF dou E naught upon dou T at constant pressure. Okay, we will put the values. N's value is 1, Faraday's value is 96,500. Then the value of this we have find out minus 1 into 10 to power minus 4. Okay, so our value comes minus 9.65 joule per Kelvin per mole. Then we have to find out the change in enthalpy. For this the formula is NFT dou E naught upon dou T at constant pressure minus NFE naught. Okay, then we will put the values. 1 into 96,500 into temperature 298 into its value minus 1 into 10 to power minus 4 minus N's value 1 into 96,500. Okay, then we have to put the value of E naught. Its value, we will put the value, it means 0.01 minus 1 into 10 to power minus 4 into here 29. This is temperature is 298, so 298 minus 298 will be equal to 0, minus 2 into 10 to power minus 6 into here 298 minus 298 square, that will be equal to 0 square. So this term and this term will become equal to 0 and its value will be 0.01. So our value, we can calculate this value, and if we calculate, we will find that this value is 2875.7 minus this value will be equal to 965. So our value will be equal to minus 3840.7 joule per mole. So it will be equal to minus 3.840 kilojoule per mole. So these are our answers. We can match. This is our option number 1. It is the right answer. Okay. Then the next important term is the specific conductance, and it is shown by the kappa. So specific conductance is given by the reciprocal of the specific resistance. It means 1 upon rho. Its unit is ohm inverse, centimeter inverse. Okay, we know that the specific resistance is given by R times A upon L. Here L is the area and L is the length. So when we put this value, then our specific conductance will be equal to L upon A times 1 upon R. Here L upon A is known as the cell constant because this value is constant for a particular cell. So it is known as the cell constant, and this 1 upon R, it means the reciprocal of resistance. It is known as the conductance. So our specific conductance will be equal to cell constant times conductance. Cell constant is given in the units of centimeter inverse, while conductance is given in the units of ohm inverse. Okay, this is a very important formula, that specific conductance is equal to cell constant times conductance, because 2 times question has been asked on this formula. Very simple formula, and if you know even the units, then you can calculate, because its unit is centimeter inverse and its unit is ohm inverse. So if you know the units, then you can calculate the answers. The answers was very simple. One question I have written here. The question is from December 2017, and the same question has also been asked in another exam. So the question is, if the specific conductance of an electrolyte solution is 0.2 ohm inverse, centimeter inverse, and cell constant is 0.25 centimeter inverse, then the conductance is, it means we have to find out the conductance, and we have given the specific conductance and the cell constant. Okay, so the conductance will be equal to, the conductance will be given by the specific conductance divided by the cell constant. Specific conductance value is 0.2 divided by cell constant, its value is 0.25. So our conductance will be equal to 0.8 ohm inverse. So very simple question. If you know the formula, you can do this type of questions. Okay, then the next term is the equivalent conductance. What is it? It is the conducting power of all the ions that are produced by 1 gram equivalent of the electrolyte in a given volume of the solution. And in the formulaic form, it is given by mole equivalent is equal to kappa times volume. Okay, if we put the value of volume, then our equation becomes kappa times 1000 divided by normality. So by this formula, we can calculate the equivalent conductance. Another is molar conductance. that is the conducting power of the ions present in the 1 gram mole of an electrolyte in a given solution, given volume of the solution. Okay, then it is given by mu m is equal to kappa times V. It will be equal to kappa times 1000 divided by molarity. Another thing is the effect of dilution on the conductance. When we dilute a solution, then the conductance will increase, specific conductance will decrease, and equivalent and molar conductance will increase. Okay, then another important thing is the variation of the molar conductance with the concentration. In the case of strong electrolyte, it is given by the Debye-Huckel-Onsager equation, and the equation is mu m is equal to mu naught m minus b root c. Here b is a constant and this mu m naught. This is the limiting molar conductance or molar conductance at infinite dilution, and this is the molar conductivity at the any concentration. Okay, if we see a graph between the molar conductance and the root of concentration, then it will be like this. This is for the strong electrolyte and this is for the weak electrolyte. So you should know this graph. The questions based on the graph may also come in the exam, and several times they had been come. And on this formula, the question has been come. In June 2013, a question was come on this formula, and we have to find out that if the concentration is increased by 4 times, then what is the effect on the molar conductance. So you should use this formula and you can find out. Okay. In the case of the strong electrolyte, the limiting molar conductance can be found out by extrapolating this graph to 0 concentration. But this cannot be done in the case of weak electrolytes. For weak electrolytes, if we want to find out the limiting molar conductance or molar conductance at the infinite dilution, then we should use the Colruy's law. According to this law, the limiting equivalent conductance is given by the sum up of the conductance, limiting conductance of the cations plus the limiting conductance of the anions. In the case of the electrolyte of the type AXB, such type of electrolytes, for this the molar conductance is given by the limiting molar conductance is equal to X into lambda naught of A. It means the conductance of the anions plus Y times lambda naught of C. It means molar conductance of the cations. Okay. There are several applications of the Colruy's law. By the Colruy's law, we can calculate the degree of ionization, alpha. It is given by the molar conductance at the concentration C divided by the molar conductivity at the infinite dilution. For a sparingly soluble salt, if we take a sparingly soluble salt, then at the infinite dilution, the molarity will be equal to solubility, and hence by this formula we can calculate. This formula is basically for molarity, but by this formula we can calculate solubility, because here the solubility will be equal to molarity, and hence solubility is given by kappa times 1000 divided by the limiting molar conductivity. Okay, this is sufficient for this video. In our next video, we will continue some other topics of the electrochemistry and some more questions. Thank you.